Defining delta exposure. Recall that delta measures the sensitivity of option price due to changes in the price of the underlying asset. So let's look at a call option first, specifically a long call position. And we can start off with the intrinsic value. That's the payoff you would get if you were to exercise the option right now. But then when we consider that options also have time value, the complete option price would be represented by the red line right there. Now again, delta measures the change in the option price due to change in the price of the underlying asset. Well, that would be like saying rise relative to run, which is really the ingredients for slope. So here's the connection. Delta can be seen through the slope of the option price curve. So let's have a look and see what's happening to the slope of a long call position. And you can see as the spot price converges towards zero, the slope of the option price curve becomes flat, meaning that the option would exhibit almost zero sensitivity to changes in the spot price. What's the rationale? Well, when the option goes really, really deep out of the money, the option stops reacting to changes in the spot price. So there it is again. So when the spot price is going towards zero and the call option is going very deep out of the money, then the delta for that call option would be zero, again indicating that the option stops responding to changes in the spot price. On the other hand, if the spot price goes up, and in theory goes towards infinity, you can see that the slope of the call price curve becomes almost at a 45-degree angle, indicating that the change in the call price is equal to the change in the spot price. So therefore, as the spot price goes up, the delta for the long call converges towards 1. Now, if you're somewhere in between, well, specifically, if you're at the money, in other words, the spot price is equal to the strike price, then the delta at that point would be 0.5. That's exactly what we have right there. And let's just quickly do the same analysis for the long put position. Again, the value of the long put position is represented by the red line. The blue line represents intrinsic value, which is the payoff if you exercise right now. But if we take into account the fact that options also have time value, that's why you see that the red line is above that blue line, indicating that the value of the option is more than just its intrinsic value. It's also got time value. So very quickly, you can see what's happening here. As the spot price converges towards zero, you can see that the slope of the put is almost at a 45-degree angle with that intrinsic value line. And that would indicate that the price of the put option is changing on a one-to-one basis relative to the spot price. Now, the only catch is it is on a one-to-one basis, but there's an inverse relationship. So you can see as the spot price decreases, the value of the put option increases. So that's why you have the minus. On the other hand, as the spot price increases and goes towards infinity, you could see that the slope of the put line becomes flattening out, and therefore indicating that the delta would be zero, indicating that as the put option goes very, very deep out of the money, it stops responding to changes in the spot price. And then somewhere, well, not just somewhere, but specifically when the option is at the money, the delta would be, between the -1 and 0, which would be 0.5. And then finally, if you look at the long underlying asset or the forward on the underlying asset, these would exhibit a one-to-one relationship with itself. For example, the spot price has a one-to-one relationship with itself, and therefore the delta for the long underlying asset would be 1 at all points in the price of the underlying asset.